How's it going, everybody? In this video, we're going to go ahead and take a look at our next topic when it comes to BGP auto discovery, and we're going to be focusing on the aspect of BGP signaling. And I'll do the same thing that I did in the E-LAN version, where we took a look at doing the auto route target and all that type of stuff, and then we'll also focus on BGP labeling. So we'll take a look at exactly how that works. I'm not going to dive into the math and how everything is determined, because honestly it's one of those things where I just spent a lot of time trying to understand it and just over my head. I don't get it. I know how to configure it, and I know that BGP signaling is, at least in my experience, is not widely deployed, although that's just my experience. You know, if you guys are out there and are deploying BGP signaling, hey, more power to you. I technically prefer LDP, but at the end of the day, regardless of which signaling method you go with, the labeling that's coming out for that still comes from the same label space if you're on any of the platforms that we're working with. So just keep that in mind. With that being said, we're going to go ahead and set up a completely new config. So we're going to be using bridge or service instance 1010, so 1010, and we're going to be using that same information for the VPN ID and for all the information that we need. We're going to be turning off LDP and bringing up BGP. So LDP is still going to run in the core. So IGP and LDP is still going to be operational, but how the pseudo wires are signaled is no longer going to be using LDP to do the signaling. We're going to be relying on BGP signaling, and we'll take a look at that as we get further along into this and stuff like that. So let's go ahead and start diving into the config. So there's a couple of terms that we have to go over really quick before we start diving into the config to understand what's all happening. So the first of which is going to be what they refer to as the VEID, or the VPLS endpoint identifier. So basically the way that this works is every endpoint is going to have its own VEID, and you don't technically have to do it this way, but looking through my notes real quick, and it's better to have it this way because then you have some uniqueness, right? So instead of having everybody the same, and this allows when BGP is trying to figure out the label space to allocate on a per endpoint basis, there's no overlap, right? So we have a unique ID, and so it's able to do whatever math it's got to go do. I've tried learning it. I legit have. I've tried, and it just goes right over my head the moment they start getting into this block and this and this and that. I've tried reading some documentation on it and tried to decipher it. This guy doesn't do math that well, so let's just be real. So I decided, you know what, I'll just remember the config and we'll take it from there. So we're going to use the same VE range, and the VE range is basically how many labels we want to allocate. So at that point, that's pretty much what we're going to be focusing on. So configuration wise, it's not a whole lot different than what we did with LDP signaling. We're just turning BGP signaling on, and then we have to suppress LDP signaling underneath BGP config. So that's going to be basically how we, so for example, when we go we're not going to be doing this on XR, the Ps. We will be using obviously XR18 as a route reflector, but the way we do this in XR, you disable LDP, and in iOS, you on the route reflector you say signaling suppress signaling protocol LDP. So sorry, I was looking through my notes because a lot of times that's what I'm doing. I reference stuff because to be honest with you, there's a lot of stuff to remember with these little specific details, and yeah, I don't want to be wrong. So with that being said, let's go ahead. Let's go ahead and dive into the config. Config is pretty straightforward, but it's going to be a lot of the same stuff we've already done before. So this is where you get into repetition. It becomes a good thing to get into. So on CSR1, we're going to go underneath the interface gig 3, and we're going to type in service instance 1010 Ethernet, encapsulation .1q 1010, and we're going to get out of there, and then we're going to type in the L2VPN, and you can't do the VFI here, BGP AD BGP signal, and then do auto discovery. the ability of VPN ID of 1010. Whoops. To go underneath here, you don't have the ability of changing the signaling method. So that option's not there. So you have no choice but to use the other variation. So I'm actually going to go ahead and turn this guy off. We'll get rid of that. So what I'm going to go do now is I'm going to go to L2VPN, and we're going to type in VFI context is going to be BGP AD BGP signal, enter key, and then we're going to type in VPN ID of 1010, and then we're going to specify underneath auto discovery BGP. We will say signaling will be BGP for signaling and discovery, not just discovery. So we're going to do that, and then we're going to type in the auto route target, because right now we're doing just E-LAN and we want to allow communication between everybody. And then in the next video we'll do E-tree and we'll change the route target values. We have that, then we're going to type in the VE ID, and the VE ID in this case here will be 1, and the VE range will be, I'll use 11. That's the minimum we can use. We're going to do that, and then I'm going to go ahead and exit out, and then we'll type in bridge-domain of 1010. Whoops. And then underneath here, we will specify member of VFI, BGP, AD, BGP signal, and we'll type member of gig 3 service instance 1010. Pretty straightforward stuff for the most part, and as you can see that most of the stuff that we're doing is, there's nothing super complicated about it. So now we have that, we're going to go do the same thing on CSR 3, 5, and 7. So as you can see, not terribly involved. So let's actually try to square this up a little bit. So do show run interface gig 3, and then we're going to do, let me go ahead and pull up Notepad. So we're going to go grab, we'll grab service instance, this guy right here. We'll paste that in. Type in interface gig 3. We can change that as we're going along. We go to the end of the line here, and then we'll do a do show run section L2VPN VFI, and we're going to come down here to this guy. This will be the next line. That's the VFI, and then do show run section bridge, and underneath bridge here we'll grab these guys right there. So then we just need to change some of these attributes as we're going along, right? So on CSR 3 we'll change this to be gig 6, and then the VEID will be 6, and then we will simply come underneath here and copy and paste that into CSR 3. Right click and paste, and underneath CSR 5 this will be gig 3, and this will be, I'm sorry, I meant to say on CSR, yeah, CSR 3 this is supposed to be, we go back to this, and let's go back to auto discovery here. We'll type in the VEID is going to be 3 and exit out of that. That's what I meant to say. Don't ask me why I said 6. And then we're going to do a VEID of 5 on CSR 5, and go ahead and grab that config right there, jump over to CSR 5, copy paste, and then on CSR 7 this will be VEID of 5, or sorry, of 7, and that should be everything we need to worry about there. And then on 7 the same process here, and there we go. So that's that. Pretty straightforward stuff for the most part. What I'm going to do next is on router 1 we'll go ahead and just configure what we need to, because if we go to CSR 1 and we do a we already have the connectivity, But what we need to do now is on the route reflectors, we need to go on to CSR2, for example. And if you look at how this is coming in, show run section L2VPN, we have, we show run section BGP. We're not suppressing the signaling here. So we need to go up to global config, and we need to go and type in router BGP1, and then type in address family L2VPN VPLS, and then on these neighbors here, we're going to come in here and copy paste, and we're going to say suppress signaling protocol and then LDP. That's going to break our other connection, but that's okay, because right now I'm not very concerned with that. I'm focusing on the connectivity for bridge domain 1010, not 1000, and we are okay there. So CSR1, we should show BGP, L2VPN, VPLS all. Actually, let me do an R, all. So 1010 is coming through. So we see this one propagate already, which is good. So we'll talk about this VEID in a little bit more detail here in just a moment. So then we're going to go to we need to do the suppress signaling LDP here on this guy as well. So router BGP1, address family IP for L2VPN VPLS, neighbor of 10.0.0.2, suppress signaling protocol LDP, and the same thing for 18. We'll get there eventually, and then you'll see that we should get some interesting outputs here momentarily when the labels come across, and we'll get that all squared away here in just a minute. But that's basically what needs to happen. So not terribly involved, but as you can definitely tell, it's something new for sure. So now that we have that, we're gonna head to go over to CSR3 and do the same thing. So router, actually on CSR1, I should be able to go do show history. Hopefully this will be done soon. Router BGP here, let's grab this config on CSR3, and we'll just do this for 5 and for 7, just to get it out of the way. And then on XR18, which is way over here, we're going to go log in, go to global config, router BGP1, and then the neighbor here, the config is a little bit different. We have to actually disable LDP on this, so we're going to type in neighbor of 10.0.0.1, and we're typing address family L2VPN VPLS VPWS, and then we're going to come down here and type in the signaling of LDP is disable, and we're going to go ahead and show config on that. Grab these few lines of config and go up to 3, copy paste, 5, copy paste, and then 7, copy paste, and commit. So there we have that, and so we'll be in good shape with that config there. So then on CSR3, we should have connectivity up and running, which we do. So now if I go back to 1 and I jump out of global config, now you can see the VEIDs coming across and the label ranges that are coming in. So if we do a show BGP, L2VPN, VPLS all, we have all of them coming across. We have 1, 3, 5, 7, which is great. And then if we look at the VEID of 3 and the block offset, and the block offset I believe is a value of 1. And look at this, we're going to see what label values we're learning and things like that. So basically what it's saying here is the block size is 11 with a base of 65. I'm not exactly sure how that's calculated, to be honest with you. You're more than welcome to dive into that. I haven't, like I said, I haven't been able to find very good documentation on it. I don't thoroughly understand it. So if the next time I go sit for the CCA Service Provider Lab exam and I get tasked with something like this and it's broken, I'm gonna have potentially a hard time fixing it because I'm not exactly sure, how to resolve labeling issues here. So with that being said, though, we have everything configured. So I should be able to go to, say, router 1, and I actually need to go configure this side here. So on interface gig 0/0.1010, I'm going to type an IP address of 10.110.110.1/24. And configuring, oh, I forgot to mention encapsulation.1q 1010. And then on 3, we're going to go to, on router 3, interface gig 2.1010, encapsulation.1q 1010, IP address of 10.110.110.3/24. And then on 5, this would be 4. Go to interface gig 0/0.1010, encapsulation.1q 1010, IP address of 10.110.110.4/24. And then lastly on 5, do show IP interface brief. Interface gig 0/0.1000. 1010. Encapsulation.1q 1010. IP address of 10.110.110.5/24. Okay, now that we have all the IP addressing in play, now we get to go back to router 1 and let's do some ping tests. Let's ping 10.110.110.3. Not pig, ping. Okay. Let's just double check this guy. Do show IP interface brief. Okay, let's check CSR3. Do show run interface gig 6. Okay, that should be working. Let's see what's up here. Show L2VPN, VFI, name, BGP AD, BGP signaling. Show run section, BGP. Okay, everything is up in that case, which is good. So show run section bridge. Oh, I mapped it to the wrong interface. That's my fault. So let's go fix that real quick. So I've set it to gig 3 here. Let me go ahead and pull that out. Remember gig 6, service instance 1010. That should fix that problem. Okay, let's try that again. There we go. So, yeah, make sure you got things mapped correctly. Alright, so with that being said, we're going to go to 4. And that should ping. That pings, and then 5. That should ping. Excellent. So we have ping reachability across the wire. CSR1, show bridge dash domain 1010. Excellent. So that means everything's working the way that it's expected to. And going from there. Now, the next thing to go do would be to go check. And one thing that I've noticed over the time is the pseudo wire, this guy right here, I believe is the pseudo wire ID number, but in hex. I believe that's basically how it's being calculated. So let's go to CSR3 and show bridge-domain 1010. All that's looking good there. CSR5, show bridge-domain 1010. Excellent. And all that's looking good, right? So now if we go from CSR4 or router 4 and I do a ping to 10.110.110.3, I should be able to ping 4 to 3. There we go. And so if I go back to 5 and I hit the up arrow, bada bing. So this rule, it's a good sign that things are working the way that they're intended to, because now that I've got those things in play, it gives me a lot of flexibility in terms of the operations. So if I go back to CSR1 and we scroll up just here a little bit, you're going to see a lot of output in these debugs. Specifically, you're going to see a lot of this, where you're going to see I believe this is the local label block, and you're going to see from VEID 7, so CSR7, a block 1 with VBS, and some of these terms I'm not 100% sure of what all they're basically trying to say. So in situations like this, if you can understand the math better than me, I encourage you to drop a link or drop some info, drop some knowledge in the comment section below, because this guy doesn't get it. I understand that BGP, there's a process that BGP goes through to figure out the label space, but beyond that, how that's determined, not really 100% sure. Documentation is not very clear, at least in my opinion. So, but it's working. So that is E-LAN with BGP signaling with VPLS. So with that being said, ladies and gentlemen, thanks for stopping by and hanging out with me. And until next time, take it easy.